Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about solving systems of three equations with substitution.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, 2x minus 4z equals 20, negative 3x plus y minus 4z equals 20, and negative 4x plus 2y plus 3z equals a negative 15. And we want to solve this system by substitution. Well, first thing I want to do is I see this first equation here. Let's go rewrite that down here. 2x minus 4z equals 20. If I pull out a 2 from both parts on the left-hand side, I'm left with x minus 2z equals 20. Divide 2 to both sides, and x minus 2z equals 10 now. Well, get x by itself, just add a 2z to both sides, and x equals 10 plus 2z. Not bad. Pretty easy to get x by itself. Well, I can use that information now with my second equation. So negative 3 here, but instead of x, I'm going to write in terms of z. 10 plus 2z, and then we have, well, just plus a y, minus 4z equals 20. So now I have an equation which is, well, z's and y's. Let's try to get, y by itself. That makes sense. Y by itself. Got lost my notes here. I want to get y by itself. So we distribute the negative 3 to both parts. So we have negative 30 minus 6z here plus y minus 4z equals 20. This should be fairly easy to get this one y by itself. Combine our like terms on each side, and well, negative 30 is the only thing that has to go over here, so we add a 30 to both sides, and we actually get a 50. Negative 6z and minus 4z is a negative 10z, and then we have plus the y comes down. Add a 10z to both sides, and now y is by itself, and it's 50 plus 10z. Not bad. So we have x by itself and y by itself, and each one is in terms of z. We're on our way. Now, we have to look at the last equation here. Okay, this one's tricky. We're going to rewrite this last equation. 4 instead of x, or negative 4 instead of x, we're putting a 10 plus a 2z that we found earlier. Then we have plus a 2. Instead of y, we just found that's 50 plus 10z. Then we had a, well, just 3z left over, and equal to negative 15. Now that fits. I think it fits, yeah. It should fit. And now we want to solve this one for z. It's the only variable there, so we should be able to. Negative 4 distributes, so we have negative 40 here, minus an 8z, plus distribute the 2 to both parts, plus 100, plus a 20z, and then we plus 3z equals negative 15. Let's combine our like terms where we can. Okay, well, we have negative 8z plus 20z plus 3z comes out to be a 15z. Negative 40 plus 100 is a positive 60 equals negative 15. Subtract 60 to both sides. 15z equals a negative 15 minus 60 is a negative 75. Divide both sides by 15, and z equals a negative 5. After all that, we got our z value, but the rest is pretty easy to get now. We take that z value, let's plug it in for this z, to get y by itself. 50 plus 10 times a negative 5. 50, 10 plus negative 5 is, well, that's a negative 50. And 50 minus 50 is 0. Same thing, take that negative 5, put it in for this z. So we have x equals 10 plus 2 times a negative 5. 2 times the negative 5 is, well, a negative 10. X equals 10 minus 10, and you can see where this is going. 10 minus 10 is 0, so I'll put it here, x equals 0. So we got a lot of zeros in this one. We can write this as a coordinate point of 0, 0, negative 5. And that's our final answer. X is 0, y is 0, and z is negative 5. Hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.